All right, your test, guys, 4.1 to 4.3 is tomorrow. I uploaded a video of me working all these out. My little one was super sick with a high fever, so I was like in the closet in the same room because I didn't want to leave her. So if it sounds like I'm like hiding or something, that's why it sounds weird. But you're going to have a variety of different problems. I'm not sure exactly how many questions are on it. I'd have to relook at it. But again, each question has a bunch of different parts. So at the end of this, I put some extra 30, 60, 90s and 45, 45, 90s so we can kind of go over. I know some of us still get stuck on those. But when you're given a triangle, and again, any questions you have after I go through this, I'll work some of them out. But when you're given a triangle and you're asked to find all of the following, all the 6 trig functions, whatever. First of all, make sure that you understand, you pay attention that it says exact answers only. What does that mean? No decimals. That means if you have a radical, you break it down, right, as small as you can, but you can have radicals in your answers. It also means you have to rationalize. We don't want radicals in our denominators. So given a triangle and 2 sides, you have to find the third side. Remember that everything is in reference to theta. So find where your theta is. The side across from theta is the opposite. The side right next to theta is the adjacent. And the hypotenuse is always the longest side across from the right angle. When you have your 2 sides and then you're asked to find the third one, you need to find the third one, we use the Pythagorean theorem. If you notice in number 3, all of these have a reason that I did each example. One of the legs here, do you guys notice this leg is 2 root 3? When you put that into the Pythagorean theorem, guys, that 2 root 3 is squared. That squared goes to the 2 that's out in front, and it goes to the root 3. So 2 squared gave me 4, and then the square root of 3 times the square root of 3 gave me 3, square root of 9, which is 3. So that's where that 12 came from. But if you ever have a number that has a number attached to a square root, when you square that, the 2, the squared, goes to both the number on the outside and the radical. All right, and then when you get to something like this, you guys notice I got down here square root of 88. Square root of 88 breaks down into a non-perfect and a perfect square. Now, some of you are going to throw that in your calculator and get the decimal. That's not what I want. An exact answer means no decimals. So in order to break down, some of you are like, I don't know how to do that. Guys, just divide by your perfect squares. Hit 88 divided by, what's the first perfect square? Right, we'll use 4. If 4 goes into it evenly, great. If it doesn't work, then say 88 divided by 9. 88 divided by 16. 88 divided by 25. You just keep using your perfect squares to see if anything breaks down. And if it doesn't, fine. Right? We have to make sure that we rationalize. We have to make sure that we don't have any square roots in our denominators, that sort of a thing, right? You guys understand? You're with me? Do you have any questions on these first 3? Again, at the end, I can come back and do one if you want me to, or something like that.
You want us to simplify those? We don't just, leave it?
Simplify as much as you can.
Okay, and if it's, the same number, you put it into 1?
Mm-hmm. Yep, okay. Yep, simplify, yep. Now, these these special rights, I'm not going to ask you to find the 6 trig functions with the special rights. You're going to be asked to find the side lengths. Now, again, with your special rights, remember there's a pattern. And I'm going to go over a bunch of these at the end of this.
Are the 6 answers under 3?
Say it again?
The 6 answers under question 3 are the same answers as question 2.
All right, number 3. Somehow I copied the same answers from number 2 over. I don't know how that happened. Actually, I do know how it happened when I was working it out with last period. But you know what? This is perfect. We'll just do it. So on number 3, our 3 sides, we have our opposite, adjacent, and hypotenuse right here. Do you guys agree with me on those 3 values? All right, so if we're going to find the sine, this worked out. Sine is opposite over hypotenuse. So the opposite side is 2 root 22 over your hypotenuse, which is what? 10? Can I simplify that? Yes. How can I simplify that? Yeah, root 22 over 5. So this is the square root of 22 over 5. Now, when you guys go to do the reciprocal function, your cosecant, this is hypotenuse over opposite. You can start with 10 over 2 root 22, right? Just go back to the absolute original and start from there. Or can't we just take this answer right here and flip it and rationalize? So this would be 5 square root of 22. And then what happens? I have to fix this, right? This becomes top and bottom by radical 22. So I have 5 root 22 over 22. Does that make sense? Now, again, you could have started with 10 over 2 root 22. You would have simplified and then gone through the motions there. So then we're going to do our cosine. Cosine is adjacent over hypotenuse. Well, the adjacent side is 2 root 3 over our hypotenuse, which is 10. If you guys leave it like that, I'm going to take points off. That's not simplified. How can you simplify that? 2 and 10. So this becomes the square root of 3 over 5. So then here, when I come over and we do our secant, secant is hypotenuse over adjacent. Again, you can start at the beginning and say, okay, 10 over 2 root 3. Or you can just take this answer, flip it and rationalize. So 5 root 3, and then I'm going to say, okay, top and bottom by the square root of 3, right? So 5 root 3 over 3. Questions? All right, then I'm going to take my tangent. What is tangent? Opposite over adjacent. Okay, my opposite side is 2 root 22. And my adjacent side is 2 root 3. Yes? Thanks, man. 2 root 3? Okay. So, right off the bat, thanks. What can I do? I can simplify. I can cross off these 2's. And now I cannot leave a root 3 in the denominator, so what's going to happen? Top and bottom by the square root of 3. So I get house times a house, just a bigger house. Root 66 over 3. And then we see if we can break that down. But you guys cannot have decimal answers. It has to be exact. So if we're going to do our cotangent of theta is adjacent over opposite. I'm going to take my tangent and flip it. So 3 over square root of 66. When I rationalize, what do I end up getting here? Say it again. 3 square root of 66 over 66. Does that simplify to what? Root 66 over 2. So we always, guys. 22, my bad, I'm sorry. You always, because I divided. You always simplify, and we always rationalize. Always. But it's really important to know your trig ratios and their reciprocals. Very important. Thank you, Suzanne. I don't know how that happened. All right, guys, if you look, like I said, 4, 5, and 6, we're going to do some special rights at the end of this. It's really important to know the pattern. You cannot have decimals, exact answers only. In a case like 6, 7, and 8, all right, 6, 7, and 8, you are given the trig function. This is the exact same problem as the first ones. What's the only thing missing? The triangle. I just didn't give you the picture. But when you're given the trig function, guys, you will be able to figure out the third side using the Pythagorean theorem, and then you can just find all of your trig functions. In this case, I think it's a good idea. God bless you. I know some of you just want to skip as many steps as possible. But I think if you're given a reciprocal function, cosecant, secant, or cotangent, I think you should note somewhere to yourself what the original is, just so you don't make silly mistakes. Because if you make a silly mistake in the very beginning here, what happens to all of your answers? They're all wrong, right? Don't make a silly mistake with math. Don't multiply when you should have added, or add when you should multiply. Don't make silly mistakes. Go back and look at it. You guys have a calculator. Somebody asked first period, Well, what's the use of having our calculator if we can't have decimals? So you can check to make sure that you don't make silly mistakes. The calculator is only going to help you with the math computation. Just makes things a little easier. Makes you go a little quicker. That's it. But once you identify your three sides, that's the only thing you need. Now you just go through and you identify whatever trig functions I ask you for. If I ask you for all six, all six. If I ask you for two, give me the two that I asked for. All right? Questions on that? All right, we will have a linear speed. Make sure that you follow directions. This says to round your answer to 2 decimal places. That means it's okay to have a decimal, right? Remind yourself, God bless you, remind yourself what all of the different rotations mean. Because when you find your linear speed and they tell you what kind of a rotation, they tell you it's a half rotation, a full rotation, 3/4, they're telling you theta, which is the central angle, and they're telling you the time. So if you look here, this first one says a half rotation. That means on your clock, you went half of a circle. Half of a circle, that's our pi, that's your theta is pi. And how much time is elapsed? 30 seconds. This is a 3/4 rotation. So you went 3/4 of a circle. Pretend that's, drawn to scale. That's going to be our 3 pi over 2 for theta. And it's our 45 seconds. If you go a quarter rotation of our unit circle, that's going to be our theta is pi over 2. And your time in that section is 15 seconds. If you went one full, what's one full? One full would be 2 pi. And how many seconds? 60 seconds. Good. Okay, good. Guys, notice I have a unit. Meters per second, centimeters per second. Units are important. You have to have units for any word problems. I'll take off points if you don't. Make sure you do. All right, when we get to our word problems, every version is going to have 2 or 3 word problems. Guys, I will not answer any questions. Did I set this up right? What do you mean by that? No, that's what you are trying to figure out. But like I told you before, it's super important to draw your triangle and actually visualize what they're telling you. It says a ladder is leaning against the side of a 3-story house. The roofer measures the angle of depression. So right away, I know that 58 is on the outside here. So I have 2 options. I can either say the angle of depression on the outside is the same as the angle of elevation on the inside. Or how did I get 32 degrees in the blue? 90 minus. I said 90 minus 58, and that's where I got my 32. The question asks, how long is the ladder? Envision what this question is. I told you guys when we were going over these, draw lines from one thing to the other to see what they give you and what you're missing. It says the base of the ladder. Where's the base of the ladder? Down here at the bottom, right? Is 65 feet from the base of the house. So here's the base of the house. You guys are seeing right there that they gave you 65 feet as the horizontal. When they say how long is the ladder, where is the ladder? Does the ladder go straight up and down? No, the ladder leans against the house. So you're looking here for the hypotenuse. If I asked you how tall the house was, what would you be looking for? The vertical. Good. Cassie, did you have a question?
Yeah, when it's talking about like shadows, it would be...
Shadows on the ground.
Okay.
Mm-hmm. All right, so look, I did the problem 2 different ways and I got the same answer. Because given the information, I used 58 as the angle of elevation, because it was the angle of depression on the outside. Then in regards to 58, I have an adjacent side, and I'm looking for the hypotenuse. If I use 32, which I used the angle of depression and said 90 minus, and I use this angle up here, well, in regards to 32, I have opposite, and I'm looking for hypotenuse. That's why I use sine. So it doesn't matter how you do it, just as long as it makes mathematical sense. You can't just put angles wherever you want to, right? And notice feet long. You have to have units on your answers. And I didn't tell you what to round to here, but I will on the test. If you have a question, okay, this one doesn't make logical sense. I was just trying to give you some different wording, but here's my car. Again, I wow you, I know, with my artwork, but here's my car, and I'm driving on a flat road. What is important that I told you that the road was flat? Okay, you don't need to account for bumps, okay. What about if I told you a steeped road to the top of the mountain? What would I be talking about? Hypotenuse. But I told you the flat road, all right? The flat road from here to the base of the mountain, 28 miles. It's a long way away. I asked you how tall the mountain was. We're out looking for the height. Here's our mountain over here. Does it make sense that it's 39 miles tall? No. But I was just trying to give you guys different wording, right? I gave you the angle of elevation. It's right here. So we're looking for how tall something is, how high. That's our vertical. How far away from the base. That's our horizontal. All right, and then we have my friend Lauren. Everybody know Lauren? Ms. Carver? Lauren's flying a kite, right? I told you guys, as soon as we talk about a kite, you think the string of the kite is going to be your hypotenuse. All right, it tells you the length of the kite string. So think about it. You're standing there holding your kite. It does not go straight up and down. And it's going to be at an angle. So this is why this is our 85 feet. I told you that it makes an angle of elevation. Angle of elevation is always from the ground. I didn't tell you how tall Miss Carver was, right? So you don't have to add or subtract anything. I just told you that from the ground. So how tall, how high is the kite? That's our vertical. If I said to you, here's a tree. Hang on one second. If I said, here's a tree, and here is Lauren, how far is Lauren from the tree? What would I be asking for? The horizontal, all right? So it's all about the wording. You've got to make sure that you understand. Yes, ma'am. Oh, hold on one sec. Cassie, question.
If it says like just like looking at the tree and then it tells you the person's height, you would add like x plus whatever how tall the person is. When would you subtract? Because that's what I don't know why.
Okay, we'll talk about a subtraction one sec. Okay. If they tell you how tall this person is, they're telling you that it's from their line of sight, and that's when you have to account from, okay, my eyes are up here, and how far is something to the ground? That's when you have to add. Questions like the smokestack question, right? They told us about the building was X amount, and then they told us that there was a smokestack on top, right? And they wanted to know just how tall is just this piece. Well, then you'd have to think, okay, well, I got to find this whole thing. And then if I want just what's left over, the difference, that's when you would subtract.
So you would subtract the two vertical lengths, like you would get to your like.
You would subtract the two vertical. They're not going to tell you that the building is 25 feet and then all of it together is 35. How tall is the smokestack? Because then you could just say 35 minus 25. Like you'll have to find both the heights. Mm-hmm. Yeah. Yeah. Let's look at these for a second. I pulled these up this morning. All right, special rights. A lot of us have questions. This sometimes is just something that is just hard to get in your brain, and I get that. I totally understand that. I've taught this a million different ways. This is one way that a friend of mine teaches it, and it just seems to stick. So follow along with me. Work with me here for a second. Let's look at this first one. All right. I never use, when I'm working this out in my brain, I never use X and Y as my letters because generally X and Y are what the book uses. So the first thing I do is I say, okay, what is the pattern? Guys, what's the pattern for a 45, 45, 90? It's 1, 1, square root of 2. Okay? The legs are both the same size. And then the hypotenuse is the same length as the leg with the square root of 2. All right, so this is what I do. Okay? I use the arbitrary letter A. And you guys are like, what does that mean? Okay, fine, watch. I'm going to replace my pattern with an A. So I'm going to put an A here, an A here, and an A here. Everybody with me? Okay. Now I say to myself, where can I put an equal sign with the length given and part of my pattern to kind of jumpstart my problem solving here? Can I say on either legs A equals anything? Right? Is there a number that A equals here? Is there a number that A equals here? Can I put an equal sign here and say 6 equals a square root of 2 and just solve that? Okay, so watch what happens when you say 6 equals a square root of 2. Solve for a. So what do you do to both sides? Divide by the square root of 2. Okay, everybody can do that. So I have a equals 6 divided by the square root of 2. Is that okay? So I'm going to rationalize. So I get 6 square root of 2 over 2. And then what does that become? A equals 3 square root of 2. Well, guys, what did you just solve? You solved a, right? So instead of a, this is just 3 square root of 2. You guys solve both of the sides. If you know the pattern and you can create a teeny tiny little equation, then you're going to solve all the sides really easily. Let's do a couple of these. Let's look at this one. All right, now think about the pattern. Just the pattern itself is what? 1, 1, and then this is the square root of 2, right? Across from hypotenuse. So now let's replace that with my arbitrary letters. I'll use a. You use anything you want. I just would not use x or y, but I'm going to say, okay, so I'm going to replace my 1 with an a, and then the a goes in front there, right? Can I set up a very simple equation with a side length that's given and my pattern? What would I write? 2 square root of 6 equals a square root of 2. Okay, so let's solve. Divide both sides by the square root of 2. So I have a equals 2 square root of 6 over the square root of 2. Well, that's gross. Can I fix it? Okay, so root 2. So this becomes 2 square root of 12 over 2. All right, there's a lot of simplifying that we can do here. What can I do first? Cross off the 2's, good. What about square root of 12? Do I just leave that? No, what does 12 break up into? 4 times 3, right? So I have a equals 2 square root of 3. So what did I just find? A. I found both of my legs. They're 2 square root of 3. Our 45, 45, 90s are a little easier because it's just the legs are the same. Our 30, 60, 90s kind of give us a little bit of trouble. Now, I found it makes it easier is to actually label all 3 of the angles. They'll always give you 2. They'll give you the right angle, and then they'll either give you 45, 30, or 60. With the 45, 45, 90, I know both the legs are the same, so you don't really have to put the other 45s. But sometimes it's just easier to write the 30, the 60, and the 90. So think about the pattern for a 30, 60, 90. What is the pattern? Just say it out loud. 1, 2, square root of 3. Okay, now we figure out, well, wait, what goes where? What's the shortest side? The side across from 30. So the shortest side is your 1. The longest side is your 2. And then the weird one is the 60. So square root of 3. Everybody with me? Okay, so I'm going to use a again. So I'm going to replace this is a. This is 2a. And this is a square root of 3. Right? Can I set up an equation? What would my little equation be that I could solve? 2a equals 16, okay? Divide both sides by 2, so a equals 8. You guys just solved this whole triangle. What is this side right here? 8 square root of 3. What is this side right here? 8. Good. Yeah.
Wait, when we're plugging it into like the 8 square root of 3, we just plug in the 8 where the a is?
Yeah. Mm-hmm.
We don't put it equal to each other?
Mm-mm.
That's only when they give you...
Mm-hmm. When that's given, yep. Yep. Once you find out what the shortest side is, the a, you literally just put the root 3 on the back of it. All right, so they gave me the 30, so I'm just going to write 60 up here just so I don't forget. So remember, the side across from 30 is 1. The side across from the hypotenuse is 2. And the side across from 60 is the square root of 3, right? So let's replace our patterns with a. So a, this is 2a, and this is a root 3. What is this simple little equation that we can start with? Okay, so a equals 2, yeah? You guys with me? All right, so now we can, this is super easy to find the rest of them. What does U equal? Side U. How long is side U? 4. Where'd you guys get that? 2 times. Good. What is side V? 2 square root of 3. Once you find the A, it's super easy. You just stick the root 3 behind the A for what's the side across from 60, and then you double it to find the hypotenuse. We'll do these. Okay, again, easy to go like this. Okay, this is 30. So think about your pattern. 1, 2, square root of 3, right? So let's stick our A's in there. This is 1A, this is 2A, and this is A root 3. So where is my simple little equation? Right here, correct? A equals what? 8. Is there much work that you could show for this question? No. This would be 8 root 3, and this would be 16. Agreed? Now, you showed me all the work I needed to see by telling me you know the pattern. But guys, it's going to say exact answers only. It's going to say no decimals. Please pay attention to that. Look at this one. Now you're like, oh man, seriously? You're going to put radicals in here? Yes, I am. But it's not a big deal. All right, my pattern. The side across from 30 is my 1. The side across from my right angle is my 2. And the side across from 60 is my root 3. So stick your letter in there. I have A, 2A, and A root 3. So where's my little equation? 2A equals 8 square root of 5. Okay, it's not great, but that's okay. So 2A equals 8 square root of 5. All right, so what do? Divide it by 2. So I have A equals 4 square root of 5. Okay, so this side, guys, is 4 square root of 5. Now I say, wait, I have to take this A and put it right there, right? So it's 4 square root of 5 times the square root of 3. A house times a house is a bigger house. So it's 4 square root of 15. That's the side right there. That make a little more sense. I know some of us get hung up on this. Let's look at this one, right? Looks like they're all the same kinds of problems. They just give you different sides, so you got to look at it. My pattern, side across from 30 is 1. The side across the hypotenuse is 2. And my side that is across from 60 is my square root of 3. So I'm going to put my pattern, my arbitrary A's. I'm going to say A, this is 2A, this is A root 3. So where's my little equation? 5 root 3 equals A root 3. Watch how easy this is, guys. If I'm going to solve for A, I divide both sides by the square root of 3, correct? You guys agree? What does A equal? 5. What is this side? 10. How'd you get 10? 2 times 5. Good. How are we? Okay?
Would you give a question where you would have to divide by a radical and set like the same one on top?
Maybe, yeah.
How would you do that?
So, like, that's not the same one on top?
Yeah, so it would be like 5 root, like 4, not 4, 5 instead.
So you feel my pain? Like this divided by root 3?
Yeah.
Okay, so we would rationalize. Root, right?
I'm done.
No, you're not. No. So it's just like this.
Okay, yeah.
Yep, no, you're not. That's fine.
Thank you.
No problem. All right, let's look at our pattern. Side across from 30. Oh, I don't see 30. Let me write it in just so I don't make a silly mistake. 1, 2, square root of 3. So let's put our pattern in. This is A, 2A, and A root 3. What's my tiny little equation I can set up to start my problem off? 2A equals 10. So divide by 2, guys. What does A equal? So Y side is 5, right? And what is the X side? 5 square root of 3. Simple.
No wonder you got 5 root 15 over 3. When you multiply it by 2, what would you do?
Oh, okay. So say this was side A and you had to multiply it by 2, right? So you guys say 2 times 5 root 15 over 3. Just like you would any other fraction times a fraction, right? So we can multiply numbers that are on the outside together. You can multiply numbers on the inside together, but you can't combine them. So I would say 2 times 5 on the outside is 10, right? Root 15 over 1 times 3 is 3. And then see if you can simplify. Good question. Do you guys have any questions about anything else, like, in the review? Like, do you want me to do any of them, or?
We're gonna have like the unit circle as well.
Yeah, I can give it to you. It's not going to help you at all. Because there's not going to be any questions. It's a good question. I didn't put any questions on there like,
Like the finding the x and the y.
yeah, no, like, given this angle on the unit circle, make sure you can.
But we have supplement and complement.
Yeah, very, very basic from 4142. It's mostly 43 stuff. But make sure that you can convert radians to degrees, right? And degrees to radians. What's the conversion factor for that one? How do you convert? 180 over pi, or pi over 180. Good, you guys know that. All right, when I talk about, complement, what is complement? Two angles that add up to be 90. Remember, it's 90 minus, or pi over 2 minus. If you are asked for the supplement, is 180 minus, or pi minus. Some of you guys got that confused. How do you find coterminals if you're asked to? Add or subtract 360. Yep, coterminal. You're going to add or subtract 360, or add or subtract 2 pi. Yep. Any other questions? Here, hold on. Any other questions? All right.